subject is microwave communication and television, and today's topic is classification of satellite, advantages of satellites and applications of satellites. So in the previous session I have said what is a satellite and why it is going to be need of satellites, and what are the advantages and what are the uses, mainly what are the uses of satellites. Okay, and that is the main working of satellites is going to be seen in the previous video or previous session. Okay, so in this session I am going to have an classification of satellites, at the same time advantages of satellites and applications of satellites. So when we are having a satellite, it is an repeater station. A satellite is nothing but a microwave link repeater station that will be revolving around the earth. That means it will receive the signals from the transmitting antenna or transmitting earth station and amplifies the signals towards the down convert, and these signals are going to be sent to the receiving earth station. So the satellite is nothing but a physical object that revolves around the large body. Okay, that is a satellite. And in our solar system, the earth and other planets is also going to be calling as satellites, which will revolving around the sun. So the natural satellite, that is the moon, is going to be calling as a natural satellite. So this is about the satellite. And what are the advantages and what is the history is going to be seen within the previous videos, and today we will discuss about the classification of satellites. Okay, so when we are having the satellite utilizations, it is basically based on number of parameters. It is division, and based on the signal processing, and based on the height of the satellite, and based on the area of working, and based on the purpose. So when we are having the satellites, these are the parameters to be classified of the satellites. So based on the signal processing, so based on the signal processing, it is classified into passive satellite and active satellite. So what is a passive satellite and what is an active satellite? So what is nothing but when we are having the passive satellites, this will receive the signals from the earth station and simply send back to the another earth station without having any amplification of signals. That is going to be calling as passive satellite. And when we are having the active satellites, these are going to be receiving the signals from the earth station, and it is going to be amplified, and that frequency is going to be changed by the transponder, that is downlinked before it will send to the earth. So that is going to be calling as active satellites. That means classification of satellites are going to be having, classification is going to be done based on the different parameters. That is, the first one is signal processing, and the second one is based on the height, and the third one is area of working, and the fourth one is based on the purpose. So the first one is based on the signal processing. That means how the signal is going to be processed. Based on that, it is going to be classified into passive satellite and active satellite. So these will be receiving the signals from the earth station and simply sent back to the another earth station. That is going to be calling as passive satellite. So when we are having the active satellite, these are going to be receiving the signals from the earth station, and it is going to be amplified, and this is going to be changing into another frequency of signals, that is going to be downlink frequency of signals, that can be done with the help of transponders, and that is going to be sent to the another earth station. So that is going to be calling as active satellites. And based on the height, so based on the height, it is going to be classified into geosynchronous satellites and at the same time non-synchronous satellites. So when we are having the geosynchronous satellites, these are also be calling as geostationary satellites. Why? Because if an geostationary earth orbit satellite is going to be placed above the earth, approximately some 36,000 kilometers above the earth, that rotates the velocity of the earth equals to the 24 hours. That means the rotation of the earth is equals to 24 hours. At the same time, that satellite is also going to be rotating to the 24 hours. So both are same. That means whenever the rotation is same, that will appearing as an stationary object from the earth. So these satellites will be appearing as stationary object to the observer, which are going to be placed on the earth. So that's why it is going to be calling as geostationary satellite. Geo is nothing but an stationary earth orbit. Okay, so that is going to be calling as geosynchronous satellites. Okay, so geosynchronous satellite means these are also calling as geostationary satellite, and in this, when this orbiter having a satellite which is placed above the earth approximately 36,000 kilometers, that is going to be rotating with the same velocity of the earth, that is equals to 24 hours. So when a ball is rotating in the same speed, if here the earth is rotating and the satellite is also going to be rotating. So for that reasons, whenever an observer which is standing on the earth, that will be observing as a stationary orbit of the satellite. So for that reasons, it is going to be calling as geostationary satellite. Okay, that is calling as geosynchronous satellite also. Okay, and the next one is non-synchronous satellites. Okay, these are not rotated at the same velocity of the earth. That's why it is going to be calling as non-synchronous satellites. Okay, so based on the height, they are going to be divided into two types. That is, under the non-synchronous satellites, they are going to be divided into two parts. That is, medium earth orbit satellites and lower earth orbit satellites. So when we are having them LEO, that means lower earth orbit satellites, these satellites are going to be placed above the earth approximately 500 kilometers, and this satellite system allows to use a simple non-directional antennas and does not suffer from the solar radiation interference. Okay, so it is very easy to use them LEO, that is they are very nearer to our earth and it is not having any problem from the solar radiations, and it is not going to be interfere of that particular satellites to our signals towards the earth station. So that is the LEO. That means the LEO is nothing but an lower earth orbit satellite, which comes at which is going to be divisions under the non-synchronous satellites, and these are going to be calling as lower earth orbit satellites. So whenever we are calling as this, whenever the satellites is going to be placed above the earth, that is approximately 500 kilometers, these satellites only allows the simple operation, and it is having the non-directional antennas, and it will not suffer any solar radiation interference. It will not suffer any solar radiations. So by that we are having a signal radiation is going to be very high in this satellites. And the next one is MEO. What is MEO means? It is an abbreviation of medium earth orbit satellites. So whenever it is going to be placed in this orbit, that is the satellite placed between the GEO satellites and LEO satellites. Okay, so between that means in between the LEO and MEO, that is the medium height above the earth's. Okay, so that MEO is going to be approximately, it is going to be placed the nothing but an 19,000 kilometers from the earth. Okay, so whenever these are going to be placed above the earth, that is about the 19 So in the MEO part, the satellites are going to be placed above the earth is 19,000 kilometers, and the capacity of the MEO and LEO satellites are relatively small when compared to the GEO satellites. Okay, this is about the MEO and LEO. So it is basically based on the height. It is going to be division into two parts, that is geosynchronous satellites and non-synchronous satellites. So geosynchronous satellite means it is nothing but an geostationary satellite. It is an geostationary earth orbit satellite which is going to be placed above the earth, that is approximately 36,000 kilometers, and when it is going to be rotating, it is having the same velocity of the earth, that is 24 hours. So for that reasons, if a observer is going to be placed on the earth, that is observing the orbit or observing the satellite, that will be observed as a stationary. For that reasons only it is calling as geostationary satellite. Okay, so the next one is non-synchronous satellites. That is going to be the opposite of the geosynchronous satellites. Why? Because it is not going to be rotating at the same velocity of the earth. That's why it is going to be calling as non-synchronous satellites. Based on this height, under the non-synchronous satellites, it is going to be division into two parts, that is MEO and LEO. Okay, so what is a MEO and what is a LEO means? The LEO is going to be satellites which are going to be placed above the earth approximately 500 kilometers, and it allows the simple operation, and it is using the non-directional antennas, and it does not suffer any solar radiation interferences. And when we are having the MEO, these satellites are going to be placed in between the GEO and LEO satellites, and these are placed above the earth curvature, that is about the 19,000 kilometers. The capacity of the MEO and LEO satellites are relatively small compared to GEO satellites. Okay, this is about our based on the height and based on the area of working. So how it is going to be working based on the area, the satellites are going to be classified into DOMSAT, that is domestic satellite, and Intelsat, that is international telecommunication satellites. It is going to be division. So what is the DOMSAT? Is nothing but a domestic satellite, and these are used by a country or a limited area. That's why it is going to be calling as domestic communication. Okay, so whenever the satellites are going to be used only by a country, that is limited area, so for that satellites is going to be geostationary satellites are going to be used for domestic communication. So that satellite is going to be calling as DOMSAT, that is domestic satellites. That means it is can be used only within that particular country or not with others. Okay, and next one is the Intelsat. So what it does means, Intelsat is going to be stands for the international telecommunication satellites, and these satellites can be used for global communication. And the first Intelsat is Early Bird. So that is going to be launched on April 16th, 1965. Okay, so whenever we are calling Intelsat, it is an international telecommunication satellite, and it is going to be used for global communication. And the first Intelsat is the Early Bird, and it is going to be launched in 1965 April 16th. Okay, this is about the based on the area of working, it is going to be divided into two parts. And not only with that, we are also having the based on the purpose of satellites, it is going to be division into communication satellites and observatory satellites. So based on the purpose, how it is going to be used is nothing but an communication satellites and observatory satellites. So communication satellites are the satellites which will be receiving the signals from the earth station and process it, and then it will retransmit it to the down of the earth. Communication satellites communicates the voice, video, signal over the entire world. That means which will be having a data to be passed to be transmitted from one place to another place is going to be calling as a communication. For that reasons, we are going to be using a separate satellite calling as communication satellites. So the satellites which will receive the signals from the earth station and process it, and it is going to be retransmitting it to the down of the earth. And the communication satellites which will be communicating the data, that is nothing but in the form of voice, video, signals, whatever it may be, is going to be the data over the entire world. Okay, and the next one is observatory satellites. These satellites are going to be used for gathering information about inaccessible terrain. That means hidden minerals, weather forecast, occurrence of earthquakes. So like this, it will send some information towards the earth station. That means these satellites are going to be used for gathering some information about the weather or weather forecasting or any minerals, any hidden parts. So like this, it is giving some information about that particular areas to the earth station. So in order to have an reducing of earthquakes, or in order to have any enemy missiles, so like this, it is going to be used for this observatory satellites. So in this session, we are going to be using only with the communication satellites only. In our these chapters, the fourth chapter is nothing but satellite communication, and most probably we are going to be going for the communication satellites only. Why? Because our subject is microwave communication and television systems. Okay, so what type of satellite is going to be used for the communication is the main intention of this. So the next one is advantages of satellite communication over the terrestrial radio communication. That means whenever we are using the general communication systems, and what it does, what is the advantages of our satellite communication. So the first one is flexibility. Satellite systems are very able to provide the communication in a variety of ways. The variety of ways means it is nothing but the communication should be done within the data. So what is the type of data means? It can be a voice, it can be data, it can be video. Okay, so whatever it may be, it can be having very flexibility to do the communication with the help of satellites. So the first advantage is nothing but flexibility. That is, satellite systems are very flexible to able to do the communication in variety of ways. That is in terms of data types. That is nothing but voice, data, video, etc. Okay, that is the first advantage. And the next advantage is long distance communication. So the name indicates that long distance communication. Why? Because if we are going to be using, what is the need of satellite means, it is mainly used for the long distance communication. In order to cover the globalized, or in order to have all of the globe, that is all of the world, we are going to be using the satellites. So for that reasons, we are having the decreasing or increasing the distance. We are going to be increasing the distance of the coverage area. So for that reasons, we are going to be calling as long distance communication. So satellite communication is very able to provide the communication all over the world. And the next one is very high speed. And whenever we are using the satellite communication systems, and it can send the signal with very high speed. Why? Because in our television or in our mobile communications, also in our mobiles, we are using the wireless mobiles, and with the help of wireless mobiles, we are using the internet also. So how it can be possible means by the usage of the satellite. Okay, so it can be used with the help of satellite. We are going to be increasing the speed of our data. So it is providing the high speed, and it will providing the coverage over the globe. I have said that whenever we are using the satellite, it is increasing the coverage area. That means it is very possible to provide the complete global coverage. So for that reasons, it will providing the coverage over the globe. Okay, so it is very easy to cover all of the globe, all of the world. That is going to be easy to have a sending of data from one place to another place. Okay, that is the one of the advantage of satellite communication over the terrestrial radio communication. And the next one is capacity. So whenever talking with the capacity is going to be more, because they are very capable of handling thousands of communication channels. Why? Because it is a best example of TV communication, that is television. In that we don't have some years ago we don't have all of the channels. We have only the one channel, that is DD national channel. Okay, but nowadays we are going to be using number of channels, that is thousands of channels are there. We are not going to use that. Okay, so whenever we require that particular channels, we are going to be choosing that channels and we are going to be using that channels. Okay, so number of channels, if we increase the number of channels, that is nothing but it has the capability to receive and send the signals also. So for that reasons there is the use of satellite. So by using the satellite, the television transmission is very easily done with that. Okay, the capacity is going to be more because of the usage of the satellite, and we can use number of channels by having the TV transmission. Okay, for having the communication channels. And the next one is reliability. The reliability of the satellite communication is very high. And the next one is point to multi-point. So I have said that whenever we are using the cables in our communication part, we are having the point to point communication and the point to multi-point communication. So point to point multiplication communication means we are nothing but the cable is going to be shared with single device. That means the one device to another device is going to be connected, not with others. The link is not going to be shared with others, only it can be shared with one device. That is going to be calling as point to point communication. And when we are having the point to multi-point communication, that means the link can be shared with number of devices. That's why it is going to be calling as point to multi-point communication. Okay, so for understanding of this, what is that? Nothing but cables are best studied to the provision of point to point circuits, whereas the multiple access property of the satellite systems means that they can provide point to multi-point service or point to point multi-point to multi-point service also. That means we can have a number of connections which are placed on the earth's curvature. We are having number of earth stations to be covered with that. That means a same signal can be covered with number of earth stations on the earth. So that is the main intention of this satellites. So by having the number of earth stations on the earth stations, we are having the coverage area is also going to be increased. So that is nothing but point to multi-point. Not only with the point to multi-point, it is also providing them multi-point to multi-point also. Okay, and the next one is cost. The cost of the cable circuits increasing with their length. Okay, when we are having the cable circuits, which will be increases with their length. So when we increase the length, automatically when we increase the cable length, the cost is also going to be increases, whereas the cost of satellite circuits is independent of the distance. It is not like that, and because when we are increasing the longer distance, we don't have any increasing of the cost. Why? Because it is not depends upon the length of the satellites. When we place a satellite for a purpose, it is going to be used only for that purpose only, not with others. So like this, the satellite cost is not going to be depends upon its length. Okay, so it is independent of the distance which is in between them earth stations. And the satellites can provide service to mobile stations. Well, because when we having the mobile communication part, in order to have a cell coverage areas, so we are going to be using cell points, and each cell point is going to be accessed with the mobile stations, and that is going to be calling as base stations also sometimes. So the base stations are having the main base stations, that is MSC, that is mobile service center. Okay, so like that we are having some controlation of that particular stations, and it is going to be having the probability to provide some services to that mobile stations also. So the satellite transmission is not restricted by geographical conditions. It is not going to be based on the geographical conditions also. Okay, so that is the advantage of satellite communication over terrestrial radio communication. And the some more advantages of satellite communication is the bandwidth of the satellite is going to be very high, and whenever it comes to the quality of the signals, the satellites are going to be providing the good quality of the signals. And whenever we are having the cost of the satellite, it is not depends upon the distance, it is not depends upon the height. Okay, it will be depends upon only the purpose of the satellite. Okay, these are the advantages of satellite communication over terrestrial radio communications. Okay, and what are the disadvantages of the satellite communication? Means the repair of the satellite is almost impossible, and the time delay between the telephone conversations and data transmission because of the varying propagation path, it is also not done with this satellites. These are the disadvantages of satellite. That means the repair of the satellite is not going to be possible, and the time delay is going to be there between the telephone conversations and the data transmission because of some variation of propagation path. Okay, so like this, it is having some drawback of the satellites. So what are the applications of satellites, where it is going to be used? I have already said that is the best example of satellite is nothing but for TV broadcasting. That means we are using the DTH systems, or for TV processing, for you having the national channels, it is also having a satellite TV. Okay, so like this we are having one of the application. Why? Because all of the homes are having the DTH connection, that is direct to home. We are not going to pay anything, just we are going to be recharging of the card. Okay, whenever it is having some, just like a SIM card, it is going to be recharged first. So that is the reason in that we are going to be having an antennas at our home of the system. That is whenever we are having some home, above the home we are going to be on the terrace, we are going to be having a separate satellite to have an DTH connections. That means directly we are going to be using the satellite. That is nothing but an earth station. When we are having an antenna on our terrace, that is going to be acting as an earth stations. So it is mainly used for the TV broadcasting system. Okay, that is the first application. And the next one is global position system, that is GPS system, already well known. Why? Because all are having the global position system. We are going to be having them to have a location of our current location. We are going to be owning of the location system, that is global position system is going to be on. And the next one is navigation purpose, it is going to be used, and it is mainly used for our military applications also. And nowadays the satellites are going to be used for radio and TV program distribution. Okay, I have already said that whenever we are going to be using dish TVs, in that also we are having a distribution center. So in order to control that distribution center, it is also having an antennas, it is having some accessing with our satellites also. Further it is going to be used, and for getting the radio signals also we are going to be using this satellites. Okay, and the next one is remote sensing applications, such as study changes in the earth's surface, that is ozone and greenhouse gases in our atmosphere, that is going to be used for getting some mapping or mining. It is going to be used. Okay, this is one of the application. And it is also used for the weather forecast applications, that is to record the weather and what is the climatic pattern around the world and what is an temperature. Okay, like this we are going to be having the use of satellites. And mainly the satellite is going to be used for internet connection, that is for using the email connections or email. Why? Because all are having the idea about the email, that is electronic mail, to have some data to be passed from one place to another place, that is from one state to another state, or one country to another country, we can access that can be possible only with the help of internet, and that internet can be accessed with our satellite. Okay, so that is the main application. And satellites can also monitor the status of the earth's surfaces, such as land or oceans, whatever it may be, it is having some monitoring status. Okay, so that is also we use them satellites. And mainly the satellites are going to be used for observe crops, forest, lakes, and also rivers. That is in order to have some monitoring systems. So in order to monitor something, in order to detect something, it is going to be used with them satellites. Okay, like this we are having number of applications of satellites. Okay, this is about our satellite applications. Let us have a quiz. So the first question is, which of the following transponders convert the uplink signal to downlink signal using two mixtures? So which of the following transponders convert the uplink signal to downlink signal using two mixtures? The first option is single conversion transponder, the second option is dual conversion transponder, and the third option is regenerative transponders, and the fourth option is dual mixture transponder. Okay, so it is very important about our quiz. Why? Because they are going to be used for ESET point of view. So please note this question, please. So which of the following transponder which will conversing the uplink frequency to downlink signal using two mixtures? What is the type of transponders? So what is the type means? The answer is B, that is dual conversion transponder. The name already indicates that dual is nothing but two. So that means a transponder which will be converting the uplink signal to our downlink signal using the two mixture means it is nothing but an dual conversion transponder. Okay, so this is an answer. That means which of the following transponders converts the uplink signal to downlink signal using two mixture means it is nothing but an dual conversion transponders. And next, in a regenerative transponders, the signal is demodulated and modulated again before transmission, whether it is a true statement or a false statement. That means in a regenerative transponder, the signal is going to be demodulated and it is going to be modulated again before transmission. So whether it is true or false, please note this question. So in a regenerative transponder, the signal is demodulated and modulated again before the transmission. Whether it is true or false, see the answer. It is yes, it is a true statement. That is, it in a regenerative transponder, the signal is going to be demodulated and modulated again before the transmission of signals. It is a true statement. And the next question is, what is the number of transponders if the satellite uses 12 channels of frequency and the frequency reuse is implemented? Then how many numbers of transponders used? That means if the satellite using the 12 channels of frequency and the frequency reuse is going to be implemented, so for that reasons how many transponders are going to be required? That is the question. So the first option is 12 and the second option is 6 and third option is 24 and fourth option is 3. So what is an answer? Please note this question. That means what is the number of transponders required if the satellite using them 12 channels of frequency and frequency reuse is going to be implemented, then how it requires, how many number of transponders required? The option A is going to be 12 and option B is 6 and option C is 24 and option D is 3. So what is an answer? That is answer is C. That is we require an 24 transponders for usaging of satellite having the 12 channels of frequency and when the frequency reuse is going to be implemented. That is the 24 is going to be required. This is an answer. That means 24 number of transponders is going to be required if the satellite uses the 12 channels of frequency and frequency reuse is going to be implemented. The next one. So which of the following is not true? Battery is only used as a backup and the first one is the battery is going to be used only for as a backup, and the B one is when in orbit solar power is always available, and when C is nothing but an battery is used for initial satellite orientation and stabilization, and the D one is the batteries are charged using solar power. In these statements, what is an false statement? It is not true means it is nothing but an false statement. So please note this question. So which one of the following is not a true? That is the statement is not a true statement. That means the battery is only used as a backup, or when in an orbit solar power is always available, and the third one is battery is used for initial satellite orientation and stabilization, and the last one is the batteries are charged using solar power, whether it is having a wrong statement or not. That is B. When in an orbit the solar power is always available. Not. Why? Because when we are having the satellites, on the satellites we are having a solar panel sheets on both sides. Okay, so number of solar panels is going to be placed, and that solar powers are going to be charged in the daytime, and that charged energy can be utilized at the night time. So that is the main reason of solar power. So for this reason it is not a true statement, it is a false statement. Why? Because the solar power is not available at always. Why? Because the solar panels are charged in the daytime, and it is going to be that charged energy can be utilized in our night time. So for that reasons it is not a true statement. Okay, the next question. telemetry command and control, that is TC&C subsystem, allows a ground station to monitor and control conditions in the satellite. So whenever we are having the satellites, in the satellites we are having number of blocks to be controlled, and in this we are also having a telemetry control subsystem, and that will be allowing a ground station to monitor and control conditions in the satellite, whether it is a true statement or a false statement. Please note this question. So when we are having the telemetry command and control subsystem, whether it is allowing the ground station to monitor and control conditions in the satellite, is it true or false? So see the answer, that is A, that is true statement. Why? Because it will having a telemetry controlling, that means which will shows the tracking and what is an latitude, what is an altitude of this, and what is the height of the satellite, and that all information can be done within this subsystem. So that will be having some information, means the ground station is helping the to control of that particular satellite, the ground station having this signals to be received. So by the receiving of signals, it can be easily control of that particular satellite. Okay, it is a true statement. And the next one is, the satellite in the earth station must be steerable even for a geosynchronous satellites, whether it is true or false. Please note this question. So the satellite in the earth station must be steerable even for a geosynchronous satellite also, whether it is a true statement or it is a false statement. Let us see the answer, that is it is a true statement. Okay, the satellite in the earth station must be steerable even for a geosynchronous satellite. It is a true statement. And the next one is, in RF tuning, what is the first local oscillator? That means what is the type of oscillator we are going to be using. The options are quartz oscillator, and the second one is frequency synthesizer, and the third one is magnetic oscillator, and the fourth one is electric oscillators. Okay, in the RF tuning sections, what is the first local oscillator? What type of the oscillator is going to be used? The first one is quartz, and the second one is frequency synthesizer, and third one is magnetic oscillator, and the fourth one is electric oscillator. So what is an answer? So first of all, note this question. So in the RF tuning section, what is the first local oscillator means? The options are quartz oscillator, frequency synthesizer, magnetic oscillator, electric oscillators. What is an answer? That is B, that is frequency synthesizer. Okay, this is the first local oscillator. So in this session, I have told about them what are the advantages and what are the disadvantages of satellite communication, and what are the applications of satellite communication. Okay, so classification of satellites. Okay, so in this session I have covered with the topics of classification of satellites, and what are the advantages of satellites, and what are the disadvantages of satellites, and what are the applications of satellites, where it is going to be used, all of the topics can be covered in this session. That means classification is going to be done based on the number of parameters, that is based on the purpose, based on the area of working. So like this, it is having number of sessions. Okay, so this is going to be covered within this session, that is classification of satellites, advantages of satellites, and applications of satellites. Thank you so much.